Alrighty, mathematicians, I did just want to make a quick video to finish up lesson one for those of us who didn't get it. So just shouting out that for the first part of this lesson, we should have gotten down our k-shifts, right? That if we shift it up or down, it's going to appear as a positive number or a negative number as a constant tacked on to the end of the equation. So please make sure you've got good notes on your k-shifts. Some of us, as we were leaving class yesterday, kind of got to finish the 8 shifts a little bit more, but I think one class didn't. So if you didn't get your 8 shift down, we'll just kind of pull this one up for a second and make sure that you add this one to your notes, right? You can, again, use your calculator to help you on this one. If you plug in these equations, you should see that if you do x plus 5 squared in your y equals, that parent is actually going to be shifted left. Right, so here we've got a positive number, but we shifted left. Which might be counterintuitive, right? That's the idea of counterintuitive, that it's the opposite of what we might think is going to happen or predict to happen. So here we have a subtract 5, and we actually shifted right when we subtract within the parentheses. And this again comes from the form of vertex form, which is our y equals a times x minus h squared plus k. So very similar in the way to point slope, that if I were to plug in a negative 5, which is really doing a minus 5 to the x value, x minus negative 5 would appear as a positive, which it does here, right? Like if I did x minus a negative 5, that's really my h shift, so my h is actually negative 5. And in this case, I've got x minus a positive 5, right? And the positive 5 is really that h shift. So thinking about the fact that like adding a positive is really subtracting, and subtracting a negative really turns into adding, will maybe help you recognize that those h shifts are counterintuitive. So they're the opposite of what you might think. The last ones we didn't quite get to were our A shifts. So question number 8 just asks like what happens if we had a negative. Well, we kind of already know from our last lesson that that means that it's going to shift instead of going up and being U-shaped, that we're going to end up with something N-shaped. Oh, is it not going to load this one? Oh, it did it the last second. Let me try this again one more time. Ooh, I think I'm bogging down my computer. I might just need to write out these A shifts. I don't know if it's going to pull it up for us to be efficient. I just wanted to do it real quick in this video. So if I can get it, I'm going to try one more time. If I can't get it, I'll write it out myself. Okay. So I think we just are going to need to write this one. So if we went down to option 9, and I've got like a y equals ax squared, we could do a y equals 5x squared, or we could do a y equals negative 5x squared, so that we do both a positive and a negative value. In this case, if I throw my parent graph on here, and my parent, remember, is our y equals x squared, and there we could graph through our origin, our over 1 up 1, over 2 up 4, over 3 up 9. On the left, I'm going to do the same values. And then I've got my parent graph that I should be getting really good at recognizing. If I change this to 5x, right, we could just throw these values into a table. Oh, I probably should have full screened this, but that's okay. In terms of a table, right, if I plug 0 into this, 0 times 0 is 0, 0 squared, and that times 5 is still going to be 0, so it's still crossing at 0, 0. But as soon as I plug in 1, 1 squared is 1, times 5 is 5, 2 squared is 4, 4 times 5 is 20. So here is where like we're seeing our shifts, where instead of going over 1 up 1, we're going to go over 1 up 5. Instead of going over 2 up 4, I'm going to go over 2 up 5, or sorry, 20. So in this case, it's kind of nice to recognize that this could be our change in x and our change in y from the vertex that we're going to do our are 1 times A, 2 times A, 3, not 2, 4, because that's our x squared values, right? So our parent counts. 3 and then 9 times A. So in this case, our A value is 5, right, based on our equation. So 1 times 5 is going up 5. Our 4 times 5 is going up 20. Our 9 times 5 would technically be going up 45. So this parabola is really going to shoot off. So I can at least grasp the first few points at 0, 0, then over 1 up 5. Then technically I'd have to go over 1 all the way up to 20. I don't think I have enough room there. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, I'd be floating off there a little bit. So our graph would just go shooting up much steeper and narrower than our parent parabola, right, at 5 times the rate of change. Same thing's going to happen for our negative function, right? If we throw our negative 1 on here and we have our negative parent, so instead of going up, we just go down from our vertex. So right 1 down 1, left 1 down 1, right 2 down 4, left 2 down 4, right 3 down 5, or sorry, 9, left 3 down 9, right? This would be my parent parabola. My y equals x negative x squared. Ugh, I'm trying to rush too much. I just gotta slow down. I just have a lot of videos to record and I apologize. In the same way, I'm going to have like my same slope count. So over 1, this time down 5, left 1 down 5, all the way over 2 down like 20, left 2 down 20. So that's where these points would be, way down off of our graph. I just don't have enough grid lines. But that's where my new slope counts would land. So if we have an A-shift, A-shifts show reflections, right? If it's a positive A, it's going to be U. If it's a negative A, it's going to be an N. And then as well as slope count changes. Right, if I usually am going over 1 up 1, as soon as I had 5, I knew I had to go over 1 up 5. If I have an A of 3, I'm going to go over 1 up 3. If it's a negative 3, I would go over 1 down 3. So our A shifts show reflection as well as slope count changes. So hopefully this finishes up our vertex form. So maybe just as like a quick little example, this would be something like y equals A times x minus h squared plus k. Putting this all together, if I had like y equals 2 times x minus 3 squared plus 5, right, and I had to graph this one, I'm going to first identify my h and my k, right, that's going to be 3, 5. That's because I have to go right 3 and then up 5. So I'm going to shift my vertex, right 3, up 5. And then from there, I've got my slope counts of 2. So it's a positive 2, and then I'm going over 1 in terms of like my change in x and change in y. And these are from the vertex, right? Usually I go over 1 up 1, but I'm going to go over 1 up 2. Usually I go over 2 up 4, but I'm going to go over 2 up 8. Usually I go over 3 up 9, but I'm going to go up 18. Right, and those would be my new slope counts. So there's my over 1 up 1 to the left and right, over 2 up 8. And this would be my new parabola. Right, there's my vertex at 3, 5 with my 2 times my slope shift. All right. Hopefully that helps you out if you had any issues with 1.1.